So this video is going to go over the heating curve of water and kind of giving you the different parts of the heating curve. And then I'm going to specifically talk about the plateaus in the heating curve. So if you were missing from class, stop this video and essentially do a trace of what you see on your screen here. So on your y-axis is going to be temperature in degrees Celsius. And on the bottom is going to be heat, okay? And then draw yourself what we call a heating curve, okay? So at 0 degrees Celsius, you need this plateau. At 100 degrees Celsius, you need this plateau, and then you need these lines connecting them. So pause the video, and then I could then give more notes. All right, so I'm going to focus on what I call the plateaus. This is where you have what we call your phase changes. So at 0 degrees Celsius, you have a mixture of both a solid and a liquid. And so if you are going from left to right, the solid is changing into a liquid. This is where you have melting occurring. And if you are going from liquid to solid, this is where you have freezing occurring, okay? At this plateau, because it is flat, there is no change in temperature. There is no change in temperature here. It stays at 0 degrees Celsius until it turns completely to liquid. So since the delta T is 0, I cannot use Q is equal to MC delta T as my calculation. Because my delta T is 0, I can't multiply things by 0 and get a result. So I have to do something else at the plateaus to figure that out. So before we get to that, let's go up to the other plateau. So up here is between the liquid and a gas. So liquid is becoming a gas or gas is becoming a liquid. So if liquid is becoming a gas, that is boiling. And if a gas is becoming a liquid, that is condensing. Again, because it is flat, there is no change in temperature. So when you are changing a phase, all you're doing is spreading out the particles or bringing the particles together, okay? So there is no Q is equal to MC delta T if my T is equal to 0. So instead, at these plateaus, I have something called a delta H for each one of these processes. So I'm gonna write them underneath so you can see them a little better. So delta H fusion is a solid going to liquid. Okay, and in my next video, I will give you definitions of it. So solid going to liquid is heat of fusion. If I'm going the opposite way, it is called heat of solidification. That is liquid going to solid, liquid going to solid. So again, the delta H on top here would be fusion. The delta H on the bottom here would be heat of solidification. Now heat, all heat has to do with is direction. So if I'm going from left to right on this graph, I am adding heat, so I'm going to put it as a positive. If I'm adding heat, that is an endothermic process. It is positive. If I go the opposite way, like the easiest example is putting liquid water into the freezer, it's becoming a solid. So I have to take heat away, so that's going to be negative. So that's an exothermic process. So when we're talking about heat and phase changes, really we're just talking about direction. So again, that's not really going to change anything. Heat of solidification is going to be a negative quantity because I have to take heat away. Heat of fusion is going to be a positive quantity. And for water, the number is 6.01 kilojoules per mole, okay? It is the same for both of these because the quantity is the same, it's just direction is changing, okay? Direction is changing. All right, so up here, you have two other delta H's, okay? And their names follow pretty nicely with what is taking place. So write down delta H of VAP, okay? Heat of vaporization, it's called heat of vaporization. And that is liquid going to gas, liquid going to a gas. The one that is going from a gas to a liquid has the same name as what's taking place. It is heat of condensation. So it's abbreviated COND, COND. And that's a gas going to a liquid. Again, similarly, heat of solidification is negative, so is condensation because I'm going the opposite way. Okay, I'm going from right to left, so that's going to be a negative quantity. And for water, the number is 40.7 kilojoules per mole, 40.7 kilojoules per mole. So this heating curve of water, okay, can be done with any substance. Now, do realize that this plateau here is 6 kilojoules, and this plateau here is 40.7. I did not draw it to scale, but this should be a much longer process than this, because again, it takes more energy to separate out a liquid to a gas than it is from a solid to a liquid. Okay, but this is what we call a heating curve. You could do this for any substance. We're going to focus mostly on water, but you have solid, liquid, and gas at different temperatures. So what would change about a substance is where does it melt and where does it boil? But its same kind of concept can apply to all substances,